Hi, I'm Daniel. Welcome in the workshop, and I have an exciting video for you today. So, I am working on a huge project, and this is for a client in Germany. And this client increased the difficulty last minute by quite a lot. So, let me show you what it is that we're actually going to build. And I can show it to you in Fusion 360. So let's start it up. And here you see the design. And basically it is a standard 43-inch cabinet. Here you can see the control panel, which is a battleship shape. I already built it, it's right over here. Now here you can see a Stream Deck, which will be the Stream Deck XL, the biggest Stream Deck I've ever used in an arcade build. And the client requested that I place two displays inside the control panel, 10-inch ones. Also very big displays, which is a lot of fun. On top of the control panel is a Teufel soundbar, and I think this could work really well. The soundbar has an amazing quality. There's a big Teufel subwoofer in the bottom part of the cabinet, and then the sound will be projected from the control panel. I did it in the last build, and that worked out really well. Now over here you can see that there is space for a small keyboard to be stored. And now let's get to the fun stuff. A request was that I would make a drawer, a glass drawer, that's a very big one, that would electronically slide out, and then inside the drawer there would be a MetaQuest 3 with MetaQuest controllers and the two Gun4IR guns placed. So very high, very big drawer. And of course this is a challenge. I already built the drawer. I can show it here. It looks gorgeous. It's made out of plexiglass, 8mm plexiglass. And there is a secret storage compartment right here behind a glass mirror to hide all the cables. So you don't see it when the drawer is here. So all the cables are hidden. It's kind of a magic trick. So this is the glass drawer, and it fits absolutely perfect. Now, and in the bottom part of the cabinet there will be three glass windows. One center window, which will be a fixed window. You can see the gaming PC inside there, beautiful gaming PC. Then we have a left and a right window. These will have plexiglass panels in front that also electronically slides to the side. This thing is going to get very complex. So they slide to the side, giving you access to the controllers. So, and another fun thing is that, as you can see, the build is white in color. Of course, we will use beautiful artwork. This is already being made, it's already printed. But because the rest of the build is all in white, the client ordered some controllers that are specially made also in white color. And I can show them because they are in this box. And I have not opened this box yet, so I'm really curious. And imagine that you press a button on the Stream Deck and that the glass will electronically slide out or slide to the side. The LED strip will go on, lighting up the controllers. This is not going to work. Lighting up the controllers, and you can grab them. Another one here, and another one here. And this is so much fun, look at it. So this is a Super Nintendo controller with gold accents. And here we have a Nintendo controller, also with gold. This is a, wow, isn't that cool? This is the coolest PlayStation 5 controller I've ever seen. So, PlayStation 5. This is an Xbox Series X, I think, or 360, no, Series X. Xbox controller. We have a Nintendo Switch controller. These are awesome. let's open the last one, which is a Nintendo 64 controllers. And the fun part is that the old controllers, the retro ones, are all in a bronze, gold bronze color, like this. And the newer ones are in shiny gold. So this will be amazing. So in this video we will have some fun. We are going to work a little bit more on the cabinet, take care of the mechanical engineering, do the electronics and everything for the drawer that comes out, and the two doors, the glass doors that will slide in and out. So let me show you where we are now. Let's turn the cabinet around. Okay. And as you can see, we are quite far in the build already. So here we are. A little bit more. The 43-inch Hyper Marquee screen is already installed. The T-molding here will be in gold. Obviously I already got it here, but I will mount it after the glass is installed and the bezel, etc. The sides will have LED lights. The glass drawer is over here. So we need to find a solution to make it open automatically with the press of a Stream Deck button, or maybe one of the buttons right here. I don't know yet. So I think it will be fun to start with the drawer, making it open automatically. So let me show you what I have in mind for that. Let me make some space here. So the idea is, or actually was, spoiler alert, it didn't work. The idea was to use these, which is basically a, I'm not sure if we are in focus, which is basically a linear movement. It has a stepper motor right here. This is some aluminum frame. This is a metal frame, and we can program the stepper motor to carefully drive the carriage, and we can mount the glass drawer to the carriage and move it like this. And I used this system before. I made some parts for a museum in automated music instruments. I made a self-playing violin using these sliding mechanics, and I already experimented with this with the drawer, but it didn't work. So let me get the camera and show you why. And that was a bummer, because it's a very clean ID. So here is the drawer, and here is the carriage. Maybe I can show it from the back. The idea was to attach the carriage to the drawer right here, and then it would slide out all the way to the back. Let me open the drawer all the way there. But as you can see, the drawer is only opened about 3/4, which is perfect for now. But when placing the control panel on top, which is about this big, you don't have enough space to look at everything, and it just looks awful. So the drawer needs to be able to open at least as far as the mirror. And when the control panel is on top, there's still enough room for your hands to enter and take everything out. So then I thought of another idea. I was playing with it already, and you can see the small timing belt there. And I thought of using here we go, a regular stepper motor like this one with a GT2 timing belt mounted. Then we would run the timing belt at the center, connect the drawer to it, and attach the servo motor underneath underneath the panel here. And I think this is what we're going to build and test next. Okay. So as you can see here, the timing belt is now still loose, and I made this insert right here that has a round over, so this runs pretty smoothly. And at the back side I made this. I also made a wrong cut here, but we will fix this later. Anyway, so I made this contraption. Let me get it in focus, which is also a round part here. So this is the way the timing belt would move. And I think I'm going to change these ones to be able to be closer together. So the timing belt is installed and it is kind of working. So it is running, but there are two problems. And the first one is that it makes a lot of noise, which is not a big problem. I can still work on that, but it's a little bit annoying. But a bigger problem is that if I push the drawer by hand, it goes really smoothly. But if I do it with the timing belt, this part is great. And then, wait, let me show you from up close. So when I push it by hand, everything is fine. And now I pull on the timing belt and everything is okay. And then here it stops. So there's some tension here. And I can also see that here. So I think the drawer slides are maybe mounted wrongly. I'm not sure, I need to test it. But the first part is going pretty smooth. And then here it's going I need to pull really hard to get it. And I hope I can get it working. Worst case scenario is that I need to ditch the timing belt idea and go for another solution, which would not be great. So let me see if I can fix it somehow. That's a bummer. I really wanted to have the drawer done and before we continue to the next part. But I think the drawer slides are crooked, or at least one of them. I know this because I had trouble with the drawers already while installing them. And even for the feel, it's okay. I think they need to be flawless for my idea to work. And hopefully my idea will work, otherwise I need to redesign the whole mechanical part of it. Anyway, let's get to part 2, which are the glass windows that slide in and out. And I already showed you what we're going to use. The linear slider. Then I have these parts here, and these are the plexiglass panels, and they will be mounted on the linear slider and slide left and right, and they will be mounted on some kind of way, I'm not sure yet how, inside the front panel. So before we start, let's get the front panel off. And it's just mounted with screws. And then it makes a lot more sense, I hope. Let's hope. And I also hope that these ones will be more easy. And now we can take it out. Hopefully, yes. There we are. So this is the front panel. Let me show you the back. So I spent quite a lot of time engineering this. This is the big plate. The computer will be installed there. And we will install some plexiglass right here. Very easy, and we will mount it and we are done. And then these are the two cutouts for the other plexiglass panels, and these will be positioned here, like this, and they will slide automatically inwards like this. Not all the way, of course, but just so you can get to the controllers. And to do this, I am using this material, and I don't know the English word for it. Polyacetal. Polyacetal. Okay, well, anyway, so my plan is to insert one piece of this material inside, which fits absolutely perfect. Then another smaller piece here, and then another larger piece on top of it. And this way we will have a U shape in which the panel can slide. Let's check if this is true. Yes. So just like this. And then the panel can easily slide in between, fixing it. Then the sliders will be placed somewhere here. And we need to make some brackets for them, I think. And we need 2 of them. So let's open the other one up. There we are. And if everything is okay, this will fit. And of course it fits. So I think I will start taking over some screw holes to be able to mount the panels on the sliders. Then we need to make some brackets for the panels. This is exciting. And then wire them up, write some code on the Arduino and see how they open up. So these fit. The only thing is that I need to get some M5 screws in the correct length. So let's go to the hardware store now. I'm not sure what time it is. 5 o'clock, yeah, still got time. So the next step will be to mount the profiles to the front panel. So let me find some profile connectors somewhere. Here they are. These are 20mm profile connectors, and they look like this. And they come with these small mounting things and some rings and some screws and an Allen key. So we're going to place one here, and one here. So they're not colliding with the glass panels, but as you can see, we need to raise them. We need to raise them just a little bit because they won't fit otherwise. Before I can mount them, we need to remove those 2 small notches. I tell you this from experience, so. So, a new day. I already worked a lot on the machine, so let me tell you what I did. I worked on the control panel a little bit, inserted the 10-inch screens, made the Stream Deck fit, did some brass inserts and some preparations, which is all fine. I sanded, filled and sanded and painted the lower panel. We are going to work on this more in this video. Oh, okay. Here we are, so everything is painted. The inside of all, except this one, they're all painted. I test fitted it, and of course it didn't fit at all, like usual while making difficult arcade cabinets. So the problem was that the stepper motors would collide with the cabinet. So there's actually a 80mm board here, of course, and the stepper motors are too high up, so I needed to make slots in the arcade cabinet, get the complete middle panel out. It was terrible. Made some slots, and now they fit. The micro switches would also collide. They were also too high up, so I changed the position of these. And now the panel fits perfectly, so I'm really happy about that. I labeled everything. I 3D printed the bracket for the keyboard, so it will hopefully fit inside here. So you can insert your keyboard right here. And these two cutouts are for the 19mm buttons that operate the drawer and the panels here. So in this box we have all the parts we will be needing. So this is the USB panel mount. This is the dimmer switch. Here in this small box we have the 12-volt DC connectors. We have them in 3 colors, so we can choose a nice color. I think we go for white. In this bag I do have some stepper motor connectors. The motor controllers for the stepper motors. Actually we need 3 of them. Let me see, what else do we have? Here we have the 22mm power on-off switch. And here are the 2 19mm switches. So now it's a great time to wire everything up, and to do this I made a schematic. This looks very complex, but it's not actually. So let me walk you through it. So the main component is the PC, obviously. The PC is the thing that operates everything. So when we press the power on-off switch, the PC needs to turn on. So the PC is connected to the master outlet on the smart power strip. And this smart power strip is indeed smart. It contains a master, or I think even 2 master ports and a few slave ports. And when the master, in this case the PC, draws current, the rest, so the slaves, will activate, will turn on. Then connected to the smart power strip are the goofy COB animated LED strips. And these will be the LEDs that are on the side of the complete cabinet and on the control panel. So when the PC is turned on, the beautiful LED show will start up. Then it's connected to a 12-volt power supply. 2 actually. We'll use a separate one for the guns, and we'll use a separate one for all the controllers, the stepper motor controllers, the Arduino, the Controlino, so all the controllers, and to all the LED rings on the switches. So this is the 12-volt power supply. So this will be automatically activated. Then all the switches, we have 2 switches for each automated door. So 4 in the lower panel for the 2 doors that can slide open, and we have 2 for the drawer that electronically comes out. Then we have the drawer switch and the panel switch, which are these ones. These are also connected, all connected to the controller. In this case I'm using a Controlino and a Arduino, and we're going to talk about them in a minute. And we have some 12-volt strips to light up the drawer, and we have some LED strips to light up the panels, and this will all make sense in a minute. A lot to do, so much to program, so much to wire up, so let's get started. And I prepared a lot already, so let me show you. Let me get the camera. So these are the panels I prepared, and these will be behind the glass doors. And here there will be the controllers. And you might ask, why is this made out of grass, or imitation grass? And this is because the artwork is all Zelda style, flowery, with landscapes and a lot of grass, a lot of green. So I think this should be really cool, especially when there is an LED strip underneath here lighting this up. So you have the beautiful white controllers. There will be a beautiful contrast between the grass and the controllers. And this is what we are going to do. And we are also going to do that in the drawer. So, and this is the right panel, and I prepared it already a little bit. This is the 12-volt power supply unit for the stepper motor controllers and for all the LED strips and for the LED rings. This is the 12-volt power supply unit for the guns. This is a DIN strip for easily interconnecting ground and power wires or power connectors. I will show you in a minute. This is the Controlino. We will be talking about this a lot in a minute. And this is a bracket for a Arduino. And it can be mounted right here with some tiny screws. So we still need to add the stepper motor drivers. We can do it on this panel or we can do it on the lower front panel if I have some room left. Not that much. I think it will be best to place them here. And these are really cheap and easy to work with. So we will be placing them right here. And now let's talk about microcontrollers. So there are a few obvious ones. The Arduino that we're going to use in this case. There is the Raspberry Pi, which I used in a lot of builds before. And then we have this new one, which is called a Controlino. And let me see if I can get it off. Here we go. You can see it. And this is the Controlino. So why do we need microcontrollers at all? And what is a microcontroller? Basically, you need it for button inputs, for outputs, driving motors, driving servos, LED animation, anything you would like to do. Basically, when a microcontroller starts up, it runs a script. You write it in your computer, you upload it to your microcontroller, it runs a script, and then everything is operated according to your script. Normally we use Arduinos. I used Raspberry Pis before, and now we are also going to use a slightly more professional one, which is called a Controlino. This looks like a PLC, and PLC are the more industry standard professional controllers used in professional automation and in factories. And this is a in between an Arduino and a PLC. So why are we using a Controlino instead of another Arduino or a Raspberry Pi? So first of all, the Controlino runs on 12 and 24 volts instead of 3.3 volts for the Raspberry Pi or 5 volts for the Arduino. So we can handle higher voltages and more current, because each output can handle up to 2 amps of current, enough for a small LED strip or for a servo motor or for a stepper motor. So each output can handle up to 2 amps. Then there are several relays built in. You have seen me use the relay boards. It becomes messy, and these relay boards can handle up to 6 amps each. So every time we need to switch on some high current apparatus, we can do it inside the Controlino as well. The other thing is that there are no floating pins here. So everything is internally pulled down, which means that everything is in off position. So we do not need pull up or pull down resistors. Everything is very stable here. Nothing bad to say about the Controlinos. They are more expensive than the Arduinos, a lot more expensive, but they are a lot cheaper than PCLs for industry use. So I think this one is around 150 euros, something like that, 160 US dollars, and worth every euro. Oh, and I forget to tell you that there are built-in LEDs for quick debugging. This makes life a lot easier. So it might be fun to write a very small script now together to show you how easy it is to write code for them. And it works with the Arduino environment. So if you're used to that, you can work with the Controlino. It has different libraries, of course, and you need to do some installations before you begin, but which is easy. So let's make some room. I forgot to tell you that I also installed new drawer slides. And the drawer is opening super smooth now. There is no friction anymore. So I hope that my original plan would still work. So we will look at it later. So now quickly, let's write a small script. So I have a button here. I already have two connectors right here. Let me insert them just like this. These will go to the Controllino. And let's write a script. Let's say that when we press a button, port D5, we make it an output port, will turn on. So we will see the LED and we hear a click. I think is D5. Yeah, D5 is also a relay port. So let's trigger a relay when the button is pressed. And let's start recording. And let's go to the Arduino IDE. And again, Controllinos are programmed in the same environment as Arduino, which makes it really easy. A lot easier than PLCs. Let's open a new sketch. Like this. And make it full screen. And here we have our empty canvas. And now it's super simple because we start with void setup. And in the setup, we determine which ports are input ports and basically which ports are output. And then we have the void loop. And in this loop, it loops our script. And basically, we're going to tell our script that we wait for button presses. And when a button is pressed, one of the ports, let's say D5, is turned high or is active. So let's go here. It already tells you put your setup code here to run once. So pin mode, make sure you have the capital letters here. Controllino underscore in. Let's do 0, which is this port right here, and 0 is an input. And we also need an output. So we do the same, pin mode. And then Controllino. And then we choose the output port. Let's say we do D5. Underscore D5 is an output. Like this. So now let's program our loop. So let's see. If digital read, and then we say Controllino underscore in 0 is high. So when the button is pressed, it is high. Then digital write, Controllino D5 is high. But we also want it to be low when the button is not pressed. So only when the button is pressed, D5 will be high. Digital write, Controllino D5 is high, but else digital write, Controllino D5 is low. So now let's test if I did not make any mistakes. Compiling sketch control is not declared in this scope. This was my mistake, obviously, because we need to include Controllino.h. And now it still doesn't work because digital write was not declared, obviously, because I made a typo. Digital write. Now let's see if it works. Done compiling, so there are no errors. Great. So now we can test it. So we can get our USB cable and upload everything to the Controllino. Let's get it in here. Then press the upload arrow and we are ready to go. So now let's connect 24 volts, or you can do 12 volt or 24 volts to the Controllino, and let's connect the button here, and the button, one side will be connected to 24 or 12 volt, the other side will be connected to in 0. And let's plug the power cable in. There we go. And now if we press the button, you can see that D5 is turned on, and in 1, this is a reference LED, so this is for troubleshooting, so you know that in 1 is working and D5 is working. So when I press the button, exactly what we programmed, D5 is turned on. Now this was a very simple script, obviously, for demonstration purposes. Imagine what you can do. You can program D5 not to be on all the time, but to pulsate, or to be on for a few seconds, or to blink, anything you like. Now, again, this was a super simple script. But now with ChatGPT and all the other AI possibilities, coding becomes much easier, and I use it a lot myself. So let's open Google Chrome. Let's go to ChatGPT, and now let's do something else. So let's write a script for Controllino Mini, in which D5 is blinking for 10 seconds after in 0, which is our button, is pressed once. So write a script for Controllino Mini in which D5 is blinking for 10 seconds after in 1 is pressed once. Now let's see if he can handle that. Okay, so he wrote the code. He wrote a pretty complex code, but let's see if it works. Copy it. Let's paste it and let's check it out first. So verify, and I already saw some errors, so let's verify. And it's giving you all kinds of errors. And one of them is the compilation error. Controllino in 0 was not declared in this scope. And what you can do now is just, this is so much fun, you can just copy the compilation error, go back to ChatGPT, paste it, and then I'm pretty sure he actually agrees with this error. And great, it comes with the Controllino library, which was missing. Let's copy the code. There are no errors, which is great. Now let's see if it's working. So we ask him if we press the button to blink for 10 seconds. So as you can see, writing code is a lot more easy than it used to be. It might help if you know at least the basics of C++ coding. So do some tutorial videos, read a little bit about it. Otherwise, it might become very difficult to troubleshoot. But just ask ChatGPT to help you out, and you can learn how to code very, very quickly. There is no shame in using new tools, especially if you're going to do more complex projects. So this was it about the programming. As you can see, it's pretty easy and it's a lot of fun, and we'll be coding a lot. So there will be a lot of code in the Controllino, and we're using the Arduino as well. And why are we using the Arduino? Because, for instance, the beautiful MP3 shield, which is available, will fit on an Arduino, and it will not work great with Controllino. So now I'm going to wire up the complete board according to the schematic. This will take a few hours at least, and when everything is ready, I think it can show you the automated opening doors and the LEDs and everything you've been waiting for. So without further ado, let's get to work. Days went into over 2 weeks. I did the full wiring. Very happy with that. I did a test fit, which absolutely did not work. That's my life. So complete wiring. I did all the programming. I even went to a flower shop and I bought all kind of decorative greenery. And I bought daisy flowers, which matches the Zelda theme, and it's also in the artwork. So this is going to be really cool. I really installed them. I'll show you in a minute. I installed the LEDs. We have strips in both of the panels, and we have a strip in the drawer. Fully animated, by the way, I'll show you in a minute. And I found a solution for the automated opening drawer, which I'm really happy with. So let's show you where we are. Let's get the camera. And there we go. So here's the drawer with some greenery, and obviously there is still some protective plastic on it, so this will look beautiful when I get it off later. You can see the LED strips, we will talk about them. Pop, 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 pom. Let's go down. You can see the controllers, the holders behind the glass panels. You can see the greenery, daisy flowers, the grass, so I will need to make custom controllers there. And now let's show you what happens when I press the blue button. And they open up. And the LEDs are now pulsing. I hope you can see this on camera. But they are prompting you to grab one of the controllers, which is absolutely amazing. And let's close it again. So this works really, really well. Now, here on this side, I finished that part. This is for the spotlights, obviously. I always love to do them. And this is the PC power on off switch. And if you want to open the drawer, you press this button here. And then the drawer comes out. And it stops. And here you can see the scenery. And obviously here will be the Meta Quest with the controllers and 2 guns. I need to position them there. But this works very well. It closes and it stops. So when I turn on the machine, let me turn it off first. Okay, when I turn it on, you can see that right panel lights up slowly, left panel lights up, and the drawer lights up. So it's all fading in, really beautiful. And another cool thing is that if the machine is in this position, so the drawer is half open, the panels below are half open or open, the machine resets itself first. Let me turn it on. So the panels close and then the drawer closes, and then everything starts up and the drawer lights up, which is really cool. And this drawer gave me so much trouble. Man, I tried so many different things. So I started with a belt loop. I tried everything, removed the drawer, made sure the drawer slides were okay. I changed the drawer slides for new ones, but there was too much friction and it didn't work at all. So I discarded that idea. Then I went for a, how do you say, a gear wheel, but that had other problems. I didn't want to mess up the drawer too much, and I needed to cut into the arcade cabinet, and this was a lousy idea. And then I found this, and these are used in toy cars. They are very rubbery and they really grab on the acrylic glass. And then I just use a stepper motor and did some experiments, and this works really well. It's quiet, it's efficient, it's safe, and that turned out to be the solution. So I'm super happy with that, and the drawer is going butter smooth. So the other thing I'm really happy with are all the LED strips. So there are two in the drawer. One is facing towards the back of the drawer, which is mounted here, and there is one pointing downwards. The LEDs in the panels are not just turned on when the machine starts, they are fading in, and when the doors are opening, they are pulsating. Anyway, they are prompting you to grab the controllers. And this is done with PWM. Super simple. And for those who are not familiar with pulse width modulation, this basically means that I'm not lowering the voltage. I'm just giving the LED strips blocks, small blocks of voltage with some time in between. So you can lower the brightness, that's the word, in a very easy way. You can just program it in any Arduino or Controllino whatsoever. So let's show you the back. And still lots of cable management I still need to do, but this is the panel. This is the right side, which is pretty empty, and obviously here is the left side with the stepper motor and the wheel and all the parts. So everything is completely hidden, and here will be the PC, obviously. So the next video will be the end result, and I can't wait showing it to you with the custom controllers on the right side, the MetaQuest installed, all the LEDs. There will be LED strips, very new ones, all around the panel and around the cabinet. So it's going to be an amazing build. Super hyped. Thank you so much for watching. I hope you liked this behind the scenes look of building an arcade cabinet. Please like and subscribe to the video. Ring the little bell icon because you don't want to miss the end result video part 2. And many more builds are coming up. Thanks again, and I will see you in the next video. Bye.